I took no love from you then, just died. I saw that day, lost my
Johnson Vintage Repairs here with a stereo receiver on the bench. It is a Sears Audio by Fisher, which may or may not have been owned by Sanyo at the time. It's got a strange model number. It's 143 and then a huge string of numbers, which is Sears' database system for keeping track of manuals apparently. So the original owner said that just want to do a checkout and had some issues on the left and right channel, balance control maybe. So probably cleaning some pots, doing some power measurements, distortion measurements. We don't have the manual, so we're probably not going to be able to do any service adjustments such as the idle current and the power balance. Let's do a little cosmetic checkup before we clean it. So a brushed aluminum faceplate with heavy machined knobs, some oxidation on the chrome, and otherwise should clean up really nice. Okay, here's the back. There's that weird part number. It's got 3 sets of speaker channels. Got your phono, 2 phonos, our aux for our signal generator, 2 tapes in and 2 tapes out for recording. Maybe there's 1, 2, 3, 4, 5 lamps, and then 3 of them are out. All right, it looked like it was just these 4 side screws. Yeah, look at that. That was easy. Let's do a quick little tour. A really big power transformer and some big Rubicon power filter capacitors. And then STK084 power amplifier packages. Oh, that's okay. One of the power filter caps leaked terribly. So yeah, one of those power filter caps completely corroded, exploded. This glue has caused a little bit of oxidation on some of these terminals here. So we're just going to do some measurements on the other side. Okay. All right, that's enough to get to the back side of this board. Got an ESR of more than 40. My judgment call was good that there's something wrong with these caps. So you see they're darkened on the back. Okay, here's the replacement caps. Got some new old stock Nichicon. For this 220-25, I had this a aluminum organic polymer capacitor. It has lower ESR, but it's a general purpose capacitor. And then for the 100, I do have an audio 100 microfarad 50 volt. All right, here I just wanted to show you how I'm adapting these capacitor clamps from these old Rubicons to these newer Nichicons. So they're both obviously 10,000 microfarad, 50 volts, just a lot smaller. I'm gonna try using this packing foam. It's mostly for like shipping China. I'm gonna cut out a little ribbon. I'll open this up and just wrap it. Okay, tighten it up. It's pretty dang tight. Can maybe cut the ribbon next time to be a little bit skinnier so it's not protruding, to make it look a little bit neater. Maybe take a razor blade here. Does that look better? Yeah. Okay, it's hard to work. Okay. Not too shabby. Taking the bottom cover off enabled us to get access to all the switches and potentiometers. So for these contact switches here, and then these push button switches here, I'm just going to flood with deoxit D5. Get some stuff in there. Get some stuff up here. All right. Enough of these here. Okay, and then got one more selector switch up there. And then the power switch is potted, I think, but try. All right, and then in all the potentiometers. Just pulling them right off. Easy as can be. Metric 14 millimeter. Look at that. Yeah, so it's just these top four screws, and then the bottom screws that came off with the service panel. So we need to get underneath. There's all the lamps. Yeah. There we go. Yeah, so now we have kind of access to these indicator lamps here. These are fuse lamps for the reception meters. Can't get my pinky in. I think I see some adhesive. Yeah. There we go. Oh, oof. Okay. It's lined up for Phonos Tuner Stereo Aux. So there's 3 panels. There is some adhesive, alright. I never thought their lights would go bad, huh? Ugh. Okay, it's alright, it's okay. The 3 panels were not enough. They had to do a bunch of glue. There's the, look how pretty that is. Then voila! Yeah, so it's seeing what kind of voltage is supplied to those lamps will enable us to figure out what kind of LED circuit's required. I just have this cover taped here so that it doesn't risk shorting anything out. So there's the dim bulb, and okay. So we can see that there are 2 working lamps here. So here's I've taken the bottom fuse out there. 5 volts AC. LED lamps that I bought are 8 volt. So I don't know if they will work in this Fisher. Let's see what kind of voltages are getting to the indicator lamp. The aux is this brown cord, also 5 volts AC. My replacement lamp is this triple LED fuse style lamp, which has a 180 ohm current limiting resistor. These were designed for a different brand receiver, which supply an 8 volt power supply. So to account for that 3 volt difference, I'm gonna have to change out the 180 ohm resistor. I actually had these SMD 68 ohm resistors. They're smaller, but with a little bit of finagling, we can make it happen. I'm just gonna blob up some extra solder to account for the smaller size. So that's kind of blobbed. That didn't seem that bad. Okay, here's one of them. And then here's almost seems the same. It is less current. Okay, so that one's drawing 12 milliamps. 20. Okay, so we maybe need to go to a smaller resistor. Let's see what we got in our resistor book. We got a 50. Yeah, the lowest we have is 50. Hey, all right, much better. Okay, so we're gonna swap out 1, 2, 3, 4, 5, 6, 7, 8 of these. So we have 15 milliamps, so 0.0153 amps times 51 ohms. That's 0.78 volts, and then 0.78 volts times 0.0153 amps, 0.012 watts. So that's an order of magnitude below the max power. Whew, that was intense. Five down. 6 down. I believe we can just off. Should be able to just hot swap them. All right. Wasn't too bad. Wasn't too bad. Woohoo! All right, let's do a dummy load power up. Okay, so far so good. All right, now we're gonna see about changing out these indicator lamps here for the phono tape box indicator. They're not burnt out, but we're in here. Well, I guess we can cut all the wires so that we can work on it away from that precious. Kind of just want to push it out. There we go. Now our LED should fit right in, right? Yep. Wow. Amazed. Yeah, kind of just smashing these. I don't know what we're doing. Just trying not to cut myself. All right, got a system going here now. Nice. All right, these are the replacement LEDs. Got a little assembly line here. All right, here's our little LED systems. Okay. All right, let's test these lights now. Okay, so it looks like they have this red diffuser. Yeah, it's interesting. Yeah, so a 5mm LED won't fit in there. So yeah, so 5, way too big. Okay, so instead of using a lamp replacement, I'm going to use a orange diffused LED with a current limiting resistor and an AC backward voltage protector, because this LED's maximum voltage rating in reverse direction is 5 volts. So it'll essentially be getting its maximum voltage constantly, which might put a damper on the lifetime. I'm just going to block that light. Okay. Oh, yeah. It goes down to that pointer. It's almost like an optical light path that lets the orange light pass through clear and then is reflected orange at the bottom. So, pretty sick. Oh, I'm not very dexterous this morning. Booyah! There we go. Hey, all right, I'm satisfied. I guess we'll try that. All right, so we wanted to re-grease the track. We're going to use this Deoxit SM22. Right. It's like what's going away. Here. Okay. Yeah, it's just these brass record out ports are just a little bit in the way. B A B C. Nice. Sweet. Gonna measure DC offset at the speaker terminals. I'm gonna have, let's activate A. everything's at middle, volume off, balance middle, on aux. We have channel A on. We have 10 millivolts. That's 19 millivolts. Alrighty, that's hooked up. And then red, channel 2 on the oscilloscope is right channel. We have the sine wave going through our aux port. And there's our scope, so showing blue as our input, and then channel 1 is red, channel 2 is green. And then we also have the data analysis of our amplitude and our frequency. Test the balance. So left only, right only. Bass. Yeah. Pretty well matched. Cool. All right, back to sine wave. Going to set it to 1 volt per division. So clipping occurs left channel at 7 volts. The probe is at 10x attenuation, so it's 70 volts peak to peak through an 8 ohm load.